Hi, Spring fans. Welcome to another installment of Spring Tips. This installment, we're going to look at Spring GraphQL, which is a brand new project that's not yet GA, that's based on it's a spiritual successor to the GraphQL Java binding, the official GraphQL Java binding and the support therein for Spring. We've taken the project in-house and put some of the best people on the Spring team on it, and they have taken the code base and turned it into something that integrates more naturally with the way that people expect to build Spring applications. Spring GraphQL still has, you can still use the low-level data fetcher API, which corresponds more or less, logically to the servlet API does for Spring MVC. But then there's a higher level component model based on controllers, based on the idea of @controller in Spring. Now, you may know that annotation. You've certainly probably used Spring MVC or Spring Web Flux. You might have used the WebSocket support introduced in Spring Framework 4. You might have used the RSocket support, but suffice it to say, @controller is not a HTTP specific annotation. It was conceived to be a general purpose description of anything that controls requests into a protocol and produces the response out via that protocol. It's a very, very useful way to think about building services, and this is yet another example of where we've taken this component model that people are familiar with and used it to create a way of describing your services, your controllers, in a way that's idiomatic and hopefully, POJO-centric, right? Plain old Java object. This API, this integration, should feel very natural to you. It's got a lot of the same concepts, including encoding and marshalling and controller handler methods, and you can even do exception handlers, things like that. So if you've ever used any of these other component models, this should be very familiar, common ground. I love GraphQL. It was originally invented in 2012 at Facebook. Facebook was confronted with a bit of a challenge. They had a bit of a tension. You see, they wanted to build different isolated microservices, but their clients needed the data that they needed as quickly as they can get it in the same view, right? They didn't want the clients, be they Android devices or iOS devices or web page, views, to have to call different microservices and compose the data on the client, because who knows what the scenario on the ground looks like for those different clients. You might be using your iPhone going through a tunnel, and that latency would be inexcusable. And it's also grossly inefficient, right? Why do that when you can have it all done on the server side, inside the data center, where these services have presumably much faster access to each other? So the composition of these different views happens in the data center, and the view is sent back to the client. The specific view that the client needs is sent back to the client. Netflix had the same problem. They started building API gateways through their Zool API gateway library, and this is a useful approach, and the way this stayed viable despite the proliferation of clients, right? I mean, who can't imagine a scenario where you have a Netflix client available to you, and a device or an ecosystem? They're everywhere. The reason this stayed viable is because API gateways written with Zool are declarative. They're small. They're meant to be a very lightweight, small layer of code, of integration code between the clients and the downstream microservices. They're almost cheap. In fact, it got to the point where you could do reloadable rules using Groovy. So the whole point was that they're declarative and they could be deployed easily, and they're more like infrastructure, not business logic. Spring Cloud Gateway serves the same goal. It's an API gateway, and it's lightweight and it's declarative, and it's even reloadable if you want it to be. But still, you have to create a new one for each client, right? To create this new view with the particular data that the client needs, because you want this data to be as quickly resolved as possible. So there's that tension. You want things logically to be well isolated and teased out into separate services, but the client wants all the data co-located in one payload that doesn't require a lot of chatter and lots of back and forth with the server. And so Facebook, when confronted with this problem, ended up creating this thing called GraphQL, which allows you to get the data that you want and no more, but you specify that in the query. So the query decides how to pull apart or tease apart the payload that will come back. This is great, right? Because it means you don't pay for the things you're not using, right? If there's a separate resource that you don't need in this particular view, you don't pay for it. Even if it's expensive and it requires another microservice, you're not going to pay that cost. This is actually a really nice fit, right? And I'm glad they open sourced it in 2015, right? In 2015, this GraphQL technology came out and people started using it. It's very popular in a lot of other ecosystems, and it's starting to get more traction here in the Java ecosystem, which makes me happy. So good stuff there, huh? And by the way, Netflix eventually became one of the poster child for GraphQL. They use it all the time now. They even have infrastructure that you can use That is a separate approach to building services, and that's more, they can do code generation, right? So in that context, you take your Java objects and it generates the schema for you. What we're going to look at is more the opposite, where it's schema-centric first. We're going to take the schema and then write the handlers that resolve that schema. And I think you're going to find that when it comes to the Spring team, more often than not, we choose schema-centric first, right? And we like to provide ways to build schema. We think that's a useful way to build services. So, for example, if you're looking at our support for Spring WS, we started with the schema, the XSD, and then you can build the controller or handlers that respond to those. When it comes to GraphQL, it's the same thing. We want to support schema first. So keep that in mind. Keep in mind that there are other approaches to doing this. And I think you'll find that in time, there's going to be some nice integration opportunities for both if you want that. But for now, let's dive right into it.
All right, so let's go ahead and build a GraphQL application. Now, obviously, GraphQL is a way to build APIs that has three very simple concepts: queries, mutations, and subscriptions. A query is a way to read data from the server, a mutation is a way to update data on the server, and a subscription is a way to read data over a period of time. Basically, think of it as a long-lived kind of request. This is ideal for ongoing data that you might want to read, sensor data, stock market updates, that kind of thing. GraphQL is typed, and so as a result, it's it's got a schema, and as a result, it's very easy to sort of introspect. This is an example of the Spacex Api. You can use it to ask the question, what endpoints or what fields are available? These fields are basically APIs. I can actually ask for information. I can say, hey, I want to get all the capsules. I want to say query capsules. Show me all the capsules. And then I can see that there's different types of data here that's available. So I can specify which ones I want, right? And this is only the data that I want. I don't get anything more or anything less. And on the server side, I'm not paying the cost of loading this other data if I don't use it, right? So the nice thing about GraphQL is, of course, I get what I want. I get only what I want. And this is great for different clients. So this is an example of where GraphQL really comes into its own. I have this nice interactive query console. I have the ability to ask the kinds of questions I want to ask. I can introspect all the different endpoints that are there. And by the way, as you'll see in just a moment, there's no reason that this means that all the APIs live on this server. GraphQL is great for data integration gateways, right? It's a great place to pull together and provide one consistent global perspective on all the different endpoints and services in your architecture. You can do that from this GraphQL API, and that in turn can delegate to other APIs. So this is a particularly nice trick to do when you're using reactive APIs, where you can do concurrent service orchestration, composition, right, scatter gather kinds of calls. But it's not complex. It's not like you have to worry about writing all that kind of stuff. It's just done for you automatically. So we're going to create a new application called API, and we're going to use the latest and greatest version of Java. We're going to use the reactive web support. Now, the nice thing about GraphQL, Spring GraphQL in particular, works with both imperative I/O, servlets, JDBC, that kind of thing, and in Spring MVC, or reactive non-blocking I/O with Spring Web Flux and R2DBC and the like, whenever possible. I mean, almost always these days, I use the reactive APIs just because it's faster, less memory, more performant, more features, more robust, more secure, more cost-effective, just better in every way, unless you have some particular use case that doesn't have an analog in the reactive world, in which case it still might be better. But so we're going to go ahead and hit generate. We'll go to the downloads directory, open this up in the IDE. Okay, so we don't have GraphQL on the Spring Initializer just yet. The Spring GraphQL support is not on the Spring Initializer just yet. So what I like to do is to actually generate my project using a snapshot version or milestone version of Spring Boot. So I'll hit Explore. I'm going to copy and paste this, and I'm going to just paste it all there. That gives me the milestone versions, and then I can just go back up here to .5.4. And now I've got access to the milestones, and I'm going to need that because Spring GraphQL is a non-GA project. While I'm here, I'm going to bump up my build to Java 17. Since that's out and it's now GA, I'll go ahead and bring in the experimental Spring Boot starter for Spring GraphQL 1.00 M2, and I'll re-import, having made all my selections. For the most part, it's just a regular Spring Boot application that's going to persist data to the database. So let's start with a record type. Okay, we're going to use record customer, and this is going to be a Java. This is a Java case class or a data class, if you will. And I'm going to persist this record to the database. So I'll use the Spring data annotation here. Okay. Oops, I need R2DBC as well. So let's see. We'll use 2.54. We'll use R2DBC. We'll use H2. We'll hit explore. And I'm going to go back and make sure I've got R2DBC and these other dependencies in my build, in addition to the Spring GraphQL dependency that I've just added. So replace all of this. I don't need the JDBC version of H2, so I'm just left with this. Reload, and there we are. Okay, so there we go. There's my basic entity. I'm going to persist this to the database by using a reactive CRUD repository. So customer integer, and now I want to actually create an endpoint to serve up that data. So this is where it starts to become interesting, right? Remember, I have an object that has two fields, ID and name. It's a record, so if you've ever seen records before, then you know that they don't have getters and setters, right? So one thing that's kind of useful is you should know, if you want to change the representation, you can always use JSON property, right? This is convenient. In our case, it'll work out okay, but if you ever did want to change it, just know that's there. You can create a record like so, new customer. And I have to specify, Stefan. Okay. And I can say customer.id for the ID. And I can specify var name equals customer.name, right? So very, very convenient, syntax there. I can just pull the data, the constituent data out. It's read only, so I can't write the data. All right, so there's my basic object graph. I'm going to need to have data in the data store, so I'm going to use Spring Boot ism to create a schema file and a data file. So schema.sql and data.sql. Okay. Create table customer ID serial primary key name var car 255 not null. Okay, there's my SQL table, and I'm going to insert some data into that data store. So insert into customer name value Josh. Let's see. Let's say Stefan. Dr. Sire, Madura, Yushin, Phil, Jurgen. Who else? That's 8 names. I need an 8th name. There's so many great people. Mark. Okay, there we go. So there's 8 random names. This is going to be enough to initialize our data store. Now I just want to see it work, right? And so I want to start exposing my endpoints in terms of GraphQL. Okay, so the first thing I'm going to do is to create a schema folder, right? So GraphQL, the Spring Boot starter, expects a GraphQL folder and then a file called schema.graphqls. And then there, all GraphQL projects have a type called query. It's a well-known type. It's just a type. There are other types. You can create as many as you like, but the convention is that you always have one called query, from which all the fields hang off, right? All the fields that represent your endpoints, basically. They correspond to the root endpoints in your API. They hang off the query, and you can navigate from there to other ones, right? So let's say that I want to have customers, right? All right, well, I'm going to create a query for customers, and that means I need a type for customer. This syntax here, the bracket, that means more than one of, okay? And I'm going to give it an ID here. I'm going to give it a name, and this maps more or less to the shape of the object in my Java code, but it doesn't have to be that way, as we'll see in a bit. So okay, there we go. So let's go ahead and create our GraphQL controller to map to that, right? And remember, @controller lives in the Spring stereotype package. It's not a web tier component, right? It doesn't specifically have to do with HTTP. That's why we have RSocket controllers, and we have WebSocket controllers, and we have Spring MVC controllers, and Spring REST API controllers, and now GraphQL controllers, right? This is all about a generic mechanism to control the orchestration of data, right? As exposed to the outside world. So we're going to create a customer GraphQL controller. And this customer GraphQL controller is going to expose the data for our customers. So the type is called query, and the field is called customers. Okay, that's very important. So let's start low level. Let's use schema name, schema mapping. So the type name is customer, and the field is, the type name is query, and the field name is customers. All right, so we're going to return a reactive stream there, and we're going to use our customer repository. So we'll inject that into the constructor, and we'll say this.repository.find all. All right, good stuff. So let's see what that does. Good, so it's up and running. We can go to the browser, localhost 8080 GraphQL, and we get this nice, console, very similar to the one that SpaceX has, right? The GraphQL Explorer. Here's the SpaceX one, GraphQL, etc. So you can now run queries, and it's kind of cool. There's a little tutorial there, right, in the bottom. You can shift Control P to prettify the queries, merge queries, run queries, autocomplete. Pretty cool, right? Okay, so let's issue a query. Now, if you don't want, remember I told you that you have to specify a query that has the same shape, as the API, or rather the query that you specify dictates the shape of the API, but something you have to start at a common place, right? So every query starts with the root, right? And what is the root for all your endpoints? Query, right? So in theory, you should be typing this. But it's kind of a convention that if you just see this, then that's the same as saying query, right? So here I'm asking for the customers. But notice that if I just leave it like that, without the specific data, it says must have a selection of subfields. Do you mean customers ... right? And it wants me to put in fields here. So what field? Well, I can hit Control Space, and I get back the customer data for, get back the ID for each customer. All right, not bad. What about the name data? Great, I'll get that, right? What about the type name, right? Type name is customer. If I wanted to, like in JavaScript or something like that, if I wanted to inspect and kind of reverse engineer that, okay? Now, again, this is that theory, this is that principle where I'm not paying for stuff I'm not using. I don't, just because I'm loading data doesn't mean I'm paying for the extra data, okay? Okay, so I've got a GraphQL endpoint. I used the schema mapping annotation to make this work. Now, this is pretty fragile, right? Imagine if I should change the type in the schema, and imagine if I wanted to resolve some other type as well. This would be stringy typed, and I don't like strings in my code. So a couple things. First of all, creating endpoints that hang off of query, even though it's just another type, like any other type in the schema, it is a special kind of special type, right? It's a query endpoint, and so it's very common to have a query type. And so rather than specifying that each time, there's a annotation called query mapping, where the default type name is query, right? So it's a specialization, kind of like get mapping and post mapping and put mapping, that relationship to request mapping, right? And then the name of the field is customers. But even this, the name of the field can be customers. We can derive that from the name of the method, okay? So query mapping, and the field is called customers. Okay, let's try that. Okay, so let's refresh. There you go, same data, right? I can, etc. So It's just cleaner that way, right? Okay, good. So now I've got query mapping, and again, most of the time you'll probably use query mapping. But remember what I said. Remember that you can actually resolve individual fields. That schema mapping is there for a reason. You can use it to resolve individual fields for a record, for an object, right? So let's suppose that we wanted to get orders related to the customer. Okay, so in this case, I want to create a new type here. I'm going to say type order, and it's going to have an ID and a customer ID. Okay, and we're going to assume that customers have orders. Okay, now this might be a separate microservice. This might be a separate microservice to which I'm making my request. But conceptually, from when somebody introspects the API, I want them to see that there are orders that belong to a customer. Therefore, it's like a one-to-many relationship. That's not how it's implemented in the database, right? There's no connection there. I might have an order service using RSocket and a customer service using HTTP REST. But from the perspective of the consumer of the GraphQL endpoint, they are one and the same. One is a part of the same aggregate, right? So how can I implement that? Well, pretty easy, right? You go to here, schema mapping, type name is customer, and we want to create order, right? So let's go here, record, order, integer ID, integer customer ID. Okay, so there's our order. And we go here, we can say we want orders. All right. And what is we're injecting a customer here, so we're going to inject that. This is the customer against which we're resolving this field. Now, when I say resolve, depending on which GraphQL implementation you use, you'll hear different jargon or different terminology for the same thing. You've got data fetchers in the underlying API that underpins the Spring GraphQL integration. That's called a data fetcher. Other APIs often call it resolvers, and it can be a little confusing, but they're all the same thing. And to make things even more confusing, you as a Spring user will probably have heard the term controller handler method, or just handler method, or something like that. So these are resolvers, these are controller handler methods, these are data fetchers. They're all basically the same thing. They're methods that get invoked when the engine, the GraphQL engine, needs to resolve data associated with a type. Okay, so here we're resolving the orders for a given customer. So it's going to load the query mapping endpoint here, and then for each customer, it's going to call this one, and this is going to return a reactive stream of orders. Now, I don't have another database to call, another service, so let's just synthesize some random data just to make this easier. Now, keep in mind, this could be a web service call. I could be using RSocket, and the nice thing about the engine here is that if we have 10 customers and that results in 10 calls to the order service, which is n+1, then you're only waiting as long as the slowest individual orders API call, right? So because the calls to the different orders endpoints are concurrent, and that's because the return value here is asynchronous. So if I'm using a reactive stream, then I don't have to block, right? I would get 10 results resolved, at the same time, as opposed to one at a time, in a serialized fashion. Okay, so now I've got let's create a stream of orders. Okay, so I'm going to say new array list order for var customer ID equals 1, customer ID is less than or equal to 8, customer ID +++, and I'm going to say orders.add new order, and the ID, of course, is this is we want this to be a custom order ID, don't we? So we're going to say order ID equals 1, order ID is less than some random number, right? Math.random times 100, let's say, okay, and then order ID ++. So we're going to say order ID and customer.ID. Okay, there we are. There's my orders list. And I'm going to turn that into a stream. Obviously, this is a stand-in for a network call that you would make. You don't normally just make fake data like we're doing here, but I want you to see what's happening here. So I could use the reactive web client the non-blocking HTTP web client to call some other HTTP REST API and get that data back. And that would be, I could just send the reactive stream that gets created from that directly back from this handler method. And that would be just fine. Okay, so now here's my orders. Here's the reactive stream. And so whenever somebody asks for that data, we'll get it back. Let's see if that works. Okay. So good, I refreshed it. Hit Control Space. No, it didn't refresh it hard enough. Let's try that again. Orders, good. Good, so there we go. We asked for orders and we got random orders for each customer. Okay, so customer ID. The customer ID is redundant, right? Obviously the ID is customer ID 1, and then all the customer ID fields for each order would be specified there. So that's a great example of where I don't want to overly specify that. Okay, good. So now I'm reading data. I'm able to get this, and you could do, imagine like you've got the customer's account, but you might have their customer profile. You might have, their posts. I mean, there's a whole related set of data, and you might want to crawl that graph, and that might resolve into several different calls to different microservices. But you're not paying any complexity here. You're not. I don't have to worry about doing that concurrently. And reactive programming gets me a lot of the way there anyway. But the fact that I can just plug this into the engine and it just does it for me, that's wonderful. Okay. All right. So now I'm reading data. We've seen how we can read data here a couple different ways. What about updating data? What if I wanted to add a new customer? Well, let's go back to our schema, and we're going to create a mutation. So this is a well-known type called mutation, right? And I'm going to add a customer. And this is I'm going to add a customer with a name, and that's going to produce a single customer. Okay, same idea, but this is the first time you've seen an argument. I'm actually creating an argument here for this field. And you can do this for read things as well. I could actually have a query, I could say customers by name, and I could say name string, and this could return customer, right? So, maybe that's a good idea. Let's try that out quickly before we move on to the mutation. So here is my customer repository. I'll create a finder called customer find by name, string name, right? And then I wanted to expose that as a GraphQL query. So query publisher customer find by name argument string name. Okay, and I'm going to say this dot repository dot find by name name. Okay, let's try this out. So I'm using argument. This is kind of like path variable or destination variable. It's just a way of us binding the parameter in terms of the concept of GraphQL, right? It's called an argument in the GraphQL world. So let's try that. Okay, so now instead of getting all the customers, maybe I want the name, and the name will be, let's find somebody who's in the data. Okay, good. And I want the customers back, but I only want the ID and the names. So, whoops, customers by name. What did I do wrong? Customers by name. Oh, it's called customers by name. I named the method like the finder. This is where it helps. Maybe it would be useful to have a constant there instead, but no big deal. We fixed it. All right, there we go. So I said, give me I want to find the record where the name is equal to Madura, and I got back that particular record. Okay, very, very powerful. Now, this is basically the incantation that you'd use when you update things as well. It's just a convention, a very useful one, that you put that kind of a finder inside of a mutation. So let's go ahead and build that now. And I could just do a schema mapping, and the type name could be mutation, and the field name could be add customer. I could totally do this, but you can see where this is going. I'm going to use mutation mapping instead, and I'm going to return a customer, add customer, string name. Okay, so we say return this.repository.save new customer null name. All right, very good. So there's my updated code, same as before. We need to put that, make that an argument. Let's do a mutation. Okay, so it's up and running. Let's go ahead and try this out. So I've got my customers by name, but first I want to invoke the add. Let's see here. I'm going to use mutation, add customer, name, Bob. I don't know who Bob is, but sure. Okay, and the results that come back are the ID, the name. Okay, there we go. So I've added customer. I got the ID of 9. Remember, we only had 8 records in the beginning. Now I can go back and paste this and, you know, let's search for Bob. Not bad, huh? I got back the result I expected almost instantly. That's very cool. So this is one of the things I love about GraphQL is that it's really not up for debate, right? I love HTTP. I think it's a super cool protocol. It gave us the wild and wonderful web, but you know, building REST APIs it quickly descends into dogma and nonsense that has very little to do on delivering results and very much to do with the purity of the approach. And as somebody who feels like he's managed to sort of get a hold on something that passes, you know, good style and good discipline for building REST APIs, I don't particularly mind it, but I can imagine it's overwhelming for somebody. It certainly was for me. It can be overwhelming if you don't know all the rules, the quirks, the oddities, the approaches that people need to care about. If you're just trying to build an API and somebody's coming at you with arguments about put versus post versus, you know, options, do you return 201 versus 202, do you use this content type, should you use hypermedia, is, you know, it can get very tedious, and you know, you have to assume that everybody's on the same page. And if you want to solve other problems like introspection, you have to have a schema, and of course schema is, you know, how do you do a schema, right? Like, do you add that yourself? Why is Swagger so popular, right? Open API, these kinds of things. They're all just there to give you some of the benefits that GraphQL just has out of the box, right? And it's not hard to figure out. If you want to send data to the server, you use a mutation. There's no discussion about post versus put. It's just use a mutation. And you might be saying, hey, look, you're using GraphQL and it's going over HTTP, but this is kind of an abuse of HTTP, right? Because you're not really using HTTP, it's just a transport. To which I say, you're absolutely right, and that's a good thing, right? We're using HTTP, but we don't need to. In fact, you can use WebSockets, which I quite like. So we're gonna go here and we're gonna, let's say WebSocket, let's say 60 seconds for this, and the WebSocket GraphQL endpoint, I'll call GraphQL as well. And you know, I could imagine, you know, some other protocol, in fact, right? The Spring GraphQL lead and Spring Web Ninja, Rossen Stoyanchev, he's awesome. He was on an episode of the podcast, and he made a great point. He said, yeah, there's no reason conceptually that Spring GraphQL couldn't be powered by RSocket. You know, the transport could be RSocket, which would be great because these are two very, very powerful abstractions. GraphQL is how I like to think about the world now. It's very simple and it's easy to build an API that people can immediately start using. And RSocket is the fastest, most natural way to build services as far as I know, right? Having tried HTTP and gRPC and a few others, I just love RSocket. So, you know, why couldn't we use RSocket as a transport? And there's no reason. And WebSockets are nice because, you know, you can do the reads, you can do the queries and the mutations through the GraphQL through the GraphQL WebSocket endpoint, no problem. But you can also do subscriptions, right, through that. And that's where it gets really interesting, is having these endpoints that give you information over time, right? So let's go back to our project here. And we're going to build a subscription endpoint, okay? So let's suppose that we had an endpoint that gave us information about events related to the customers, right? And so these customers are, you know, things are happening all the time. They're being added, they're being changed, deleted, whatever. So I want to have a way to consume that event, okay? So first of all, I'm going to create a subscription endpoint, a subscription type. So type subscription. All right. And that's a well-known one as well. So I'm going to create an endpoint here, a field called customer events, ID. And I'm going to return a customer event. So this is a stream of customer events. And normally I would think about it as bracket customer event, right? If it doesn't have a bracket, it's a single value. If it's got a bracket, it's a plural value. But in this case, it actually makes sense to keep it like this as just one value, because you're going to get the same endpoint over and over, as opposed to calling the same endpoint and getting multiple values over and over, or multiple values, right? What I'm actually getting is I'm subscribing to an endpoint, and I'm going to get one value each time there's a new value to be got. So that makes sense. So now I'm going to create a customer event. And this customer event is called customer. And it's going to have an event type called customer event type. And this customer event type, in turn, is an enum, actually. I'll just create an enum, right? So updated, deleted. All right, very simple, very straightforward. Okay. And I want to map that to my code, my Java code. So let's go back, and I'm just going to fake some data to make this easier. So we're going to use subscription mapping. And our endpoint is going to just produce a stream of customer events. So customer events. And we need to, of course, create this customer event and a record. It'll be a customer event and a customer event type. Okay. We need a customer event type. So the customer event type will also be an enum here on the Java side. So customer event type. All right. And what kind of fields do we have here? What fields? Well, we have updated and deleted. Almost directly, line for line, what we typed in the Spring, in the GraphQL, right? Actually, customer event type, I think you could probably even leave a comma there. That's probably valid still. And if it is, then that means you could just literally copy and paste it. That's very, very familiar. It's hard to get that wrong, right? Let's see. Good. So there's my event. There's my customer event, which has the state of the event and the customer to whom that event applies. And then our endpoint here is going to give us all the events for a particular customer. So let's resolve this. We're going to say, given an argument, customer ID. Whoops, and we want this to be an integer, customer ID. And we need to update this. That says customer ID, right? To be very clear. All right, we're going to take the data. We're going to say repository.findById, customer ID, and we're going to then flat map it into a reactive stream of records. So customer, and we'll come back. I'm going to delay the elements that come back. Right, I'm going to create a sequence of results so we have something to look at over time, and I'll just get 10 elements. Let's say take 10. Okay. Now this. My job here is to return a reactive stream of value. So I'll say stream equals stream. I'm going to use the Java 8 API, stream.generate new customer event, customer math.random times, well, let's see. What do I want to do? I want to say the new customer event, right? So math.random is greater than 0.5, I suppose. So 50-50 chance of it being deleted or updated, right? And obviously this is not actually, I'm not deleting stuff, right? Nothing is actually happening, but it's just an example. It's showing you a feed of data, right? A feed of information. So there's my Java 8 stream. I'm going to turn that into a reactive stream. I'll say publisher.fromStream stream. Okay, good stuff. So there we go. There's my customer events endpoint. And I want to consume this. This is a customer events endpoint. I'm going to consume this from WebSockets. The GraphQL endpoint the browser doesn't do a particularly great job of letting me interact with subscription endpoints, which is a bummer because I would love to be able to see that interactively. So we need to do, we need to eat the whole elephant, as it were, and we need to like create a HTML page using a JavaScript client that actually talks right to the GraphQL endpoint, and that's fine. We'll just do the old-fashioned way. So I happen to have pre-written that. I'm not going to make you sit through me ruining JavaScript. So here we go, file, index.html, and voila. Okay, so let's review what this thing is doing. Okay, so I'm using this GraphQL web service, WebSocket rather. I'm using this GraphQL WebSocket JavaScript client. You can just link to it. And I've got a class. Can you believe it? It has a class and a constructor. We did it. We did it, everybody. We did it. We did it. It finally happened. JavaScript has some of the things that make Java nice. Good job, everybody. Well done. I'm using the GraphQL WebSocket client to create a client pointing it to a URL. We'll look at what that is in a second. And I've got two methods here. One is just for subscriptions, and basically it's a query and then a callback, like an actual callback. And then the other one is for just queries and mutations where I just want the result. There's only one asynchronous result, right? For which a promise and async await are ideal, right? So here it's basically the same API. Behind the scenes, they're both calling this.client.subscribe, right? So that's what's happening here. This.client.subscribe, this.client.subscribe. But because this is just for single values, it's not an ongoing stream, I'm wrapping it in a promise, which is great because I can use it with async await in JavaScript, right? And then I'm using that JavaScript client that I just created, a new GraphQL. It's called, I'm creating a client in my little CRM class. And I'm connecting as a WebSocket client to the WebSocket GraphQL endpoint. And I'm going to read the customers here using this query, customers ID name. Okay, I'm going to get the data and the customers. Now I want to add data. I want to add a customer. So here's my query using the mutation. So you've seen this. This is exactly as we put in the GraphQL client. And then for the subscription, I'm querying for the customer and the event, right? And so if we look at that, that should be what we need. Good, right? So there we go. That's a little bit of everything. And I'm going to just use all of this. So when the JavaScript page loads, I'll create a CRM instance. I'll subscribe to customer updates, customer events, and print out the ID, the name, and the event, and the time, right? I'm going to then add a customer, Bob, and then I'll read all the customers and confirm that this value has been added, right? It didn't exist before, but it does now. Okay, so let's go ahead and restart. That should work. Fingers crossed. Okay, we'll go to here, and we're going to go to index.html. Oops, let's see, what have I done? Closed event. Oh, the query was incorrect. What did I do? I said customer event. Oh, it's called event. And what did I put in my JavaScript, I wonder? I called it event, customer, and event. What's wrong with that? Customer event, customer events. Oh, it's called ID. Okay, I need to change my JavaScript there. See, this is why it's nice to have types and schema. Okay, take 3. Cool. So there you go. I'm getting, I'm getting random updates. Obviously, I just synthesized it. Stefan, the event type is wrong, right? So subscription is complete. Here's all the customers, all 9 of them, including Bob. But the subscription I'm getting back, the event is customer ID, name, and event.event. So is it, what is the event type? Customer event type. it says event.customer.name and then event, and that's the reactive stream. So it's a customer event and it's a, type. There we go. There you go, deleted, updated, etc. I'm just doing math at random, deleted, whatever. So you can see that, and it's all just WebSockets. It doesn't really matter. I just send in the query and that's it. The query speaks for everything. There's no questions about how to form the right envelope and the headers and all that. Now, obviously, we've just begun to scratch the surface here. You can see that GraphQL works just fine on top of the reactive stuff. It also works just fine on top of imperative IO. There's also a really good Spring security integration already provided out of the box. We're doing more and more work to make it work nicely in a Spring Data context as well. The use case, of course, is that we want your Spring Data repositories to be able to dynamically project just parts of the graph so that when you send a query asking for just the ID and the name, we don't load the full entity behind the scenes, right? And so this is very, very convenient. Obviously, in this case, we only had 2 fields in our entity, and we synthetically added that third one called orders by calling another microservice. So in this case, it wasn't that big a deal. But imagine you had an entity in the database that had 10 fields, and the client only wanted 2. Well, now you're ferrying around those extra 8 for no reason. So work is being done underway there. There's already some interesting stuff you can do with Spring Data and GraphQL, and good stuff with Spring Security as well. So watch the space. This stuff is getting very good. Remember, this is built on top of the GraphQL Java client that's already been out there for years. So while Spring GraphQL is still experimental, I expect it'll be, it's trending towards GA sooner rather than later. And for good reason, because we're not building a brand new code base. We're integrating an existing tried and true and well-tested implementation instead. As always, thanks so much for watching, and we'll talk to you next time.